Hello everyone, welcome to Cypher page, and today we are going to solve Leetcode number 3532, that is path existence queries in a graph 1. It is a medium level question, so let's read this question what is given. Uh, so in this question you are given an integer n representing number of nodes in a graph labeled from 0 to n minus 1. Okay, so this n represents the number of nodes from 0 to n minus 1. You are also given an integer nums of length n sorted in non-decreasing order, that is important, and an integer max diff. An undirected edge exists between the node I and j if the absolute difference between nums of I and nums of j is at most max diff. Okay, so that is nums of I minus nums of j should be less than max diff. Okay, you are also given this is the important condition in this question. So we can now we can say that if this is true, like if nums of I minus nums of j is less than equals to max diff, that means the nodes are connected. What we can say, the nodes are connected. Otherwise what will be otherwise condition? Otherwise we can say if nums of I minus nums of j is greater than max diff, then we can say there is no edge between the nodes. That means this, if this condition hits, then we can say in a graph another new component is created. That means if we have a connected graph of 0 and 1, 0, 1 and 2, and there is a in the nums array there is a node with a length greater than nums of I and nums of j greater than max diff. That means this is not connected with the actual graph. So there is a component, extra component at this condition. There is an extra component. So we what will say, a component will be plus plus. That means a new component is there. Okay, the number of times this condition hits, a component will increase. Okay, in a graph. So you are also given a 2D array. What we have queries. These are the queries that you are giving: source node and destination node, whether there exists a path between the nodes or not. Okay, this is what you need to find out, and you have to return a boolean array with the size of queries array, and you have to return for all these nodes. Okay, UI and VI. Okay, so let's see this example first. In this example, what we are given? We are given a number of nodes equals to 2. Okay, so we have a nodes from 0 to n minus 1. So our first node will be 0 and the second node will be 1. Now come to nums array. Nums array 0 index, 1 index. Okay, so for the 0th component, I am just saying we have to maintain a the number of components in the question, and also we need to understand which node comes under which component. So for 0 now I am just saying I will maintain a array component in which I will I will create the size with 0 and initialize with 0. That means right now it is a component with 0. Or we can say this is the, or we can say this is the first component. 0 represents the first component. Okay. So if for the 0th index, for the 0th node, the component is 0. Now for the first, we have to check whether there exists a edge or not. So for finding the edge, what is the condition? We have to check this. We have to check modulo of these two, but here it is non-decreasing order, so no need to take modulo. What I will do, non-decreasing, that means increasing. Okay, not increasing, so somewhat. So what we will do, what I will do, I will write nums of j before. I mean to say, I will say nums of I minus nums of 0 should be if it should be less than equals to max diff to satisfy they belong to same component. Why I am giving stress on component? Because at last we have to find out whether there exists a path between u and v or not. So if if they are connected component, if the nodes are part of component, then we can have a path between them. So this is what I'm giving stress on. So what I will do, I will just check this condition. Here we can say the max diff is 1. So if I do subtraction 3 minus 1, that is 2. So the edge is not possible. Now let's come to the queries. In the queries we can say the first query says 0, 0. That means to the node source and destination are same and they belong to a same component. That means the path is feasible, the path is possible. That means for this we will return true. Now for 0, 1 there is no edge. No edge means no path. No path means the condition will be false. That is true. So this is how you will return the question. Okay. Here also there is an example. Here we can say that there are 4 nodes 1, 2, 3, 4. Here nums of 0. Here they have initialized with 1. Okay. Let it me correct it. Let it be 0. Let it be 1. Let it be 2. Let it be. Okay. Sorry. I didn't saw that. They have already made a very good graph. So what we have to do, we have to see for the 0. For the 0 the distance is already 0. Now for the first node, we will check for the first node to 0th node, that is 5 minus 2. 5 minus 2 is 3, but the max diff is 2, so edge is not possible between these two. Okay. Now for 2 comma, these are the indexes I have written. Now for 2 comma 1, is there a path? From 6 minus 5 is equals to 1, and 1 is less than max diff. That means there is a path exists between them, and it is an undirected path. That means from 1 you can go 2 and 2 you can go 1. Now for 2 comma 3, 2 and 3, let's see whether there is a path. So 8 minus 6 we will do, and it is equal to max diff. That is 8 minus 6 is equals to 2. That means there is a path. That's why we will connect this edge as well. So this is how we will make the number of components. Here we can say the number of components will be, the first component will be this and the second component will be this. So this is how we can get the number of components, and if there is they are connected, that means If they are part of the same component, then that means we can reach the edges. So I hope you got the concept. Now let's try to implement this question. So here you can see this is the path existent queries in graph 1. What I will do, I will first create a vector in which I will store uh, component in which I will store which component, which nodes belong to which components. Okay, so what I will do for component, for the node 0, it will belongs to the first component. I can write it like this, or it will belong to a 0 component. The thing is same. Okay, I need to maintain a variable in which I will just have the number of components. Okay, so what I will do, I will iterate over this nums array from I equals to 0. Sorry, I equals to 0 we have already done. For I equals to 1, I less than n, I plus plus, what I will do, I will just check if nums of I minus nums of I minus 1 is, if it is less than equals to, then there is no issue, but I have to count the number of components. So I will say if they are equals to max, greater than max diff, then what I will do, I will write component, this compo variable increase. Otherwise component, if they are a connected component, component of I equals to compo variable. Okay, so this is how you will do. Now we have to return our answer in boolean factor. So I'm just making a vector of bool in which I will store all my answers. I will create a answer this vector. Now I will iterate over the queries. I will iterate over the queries, and our u will be q0 and our v will be q1. Okay, q1. Thereafter I will check boolean, or I can directly just answer dot push back the condition. Okay, right. Okay, answer that push back the condition if they are a part of same component or not. So I will write if component of u is equals to component of v. If this condition is true, that it will store true, otherwise it will store false, and we have to return this vector. So let's run this code, and you can see our answer is submitted, running fine. And now submit this question. So you can say our answer is submitted successfully. I hope you liked the video. Thank you.